All right, two more. Okay, so phenixbenzimine. You'll know this very well at the end of this. Blocker, alpha blocker, both alpha 1 and alpha 2. Methylamine is going to be ganglion blocker. This is going to be reflexes. And then finally you have propranolol is going to be a beta blocker. So in this case, once again, you have epinephrine alpha 1, beta 1, beta 2, norepinephrine alpha 1, beta 1, phenylephrine alpha 1, isoproterenol beta 1, beta 2, albuterol beta 2. Alrighty, so let's take a look. Once again, here's my little diagram: alpha 1, beta 1, beta 2, and beta 2. Remember, alpha 1's increased blood pressure, beta 1 only increases systolic, and the beta 2's will decrease systolic and diastolic to an equal amount. So in this case, control, let's take a look. Blood pressure goes up. So in the case of blood pressure going up, it could be high dose epinephrine. It could be high dose. That's possible. Norepinephrine. It could be epinephrine. Okay, epinephrine is okay. Epinephrine is okay. Phenylephrine. Okay, so phenylephrine is only alpha 1. So if it was alpha 1, you would expect it to increase equally. Systolic and diastolic should look very close to systolic and diastolic before the effect. So in the case of phenylephrine, cannot be phenylephrine. Isoproterenol, beta 1 and beta 2. Beta 2 is going to be mostly going to be decreasing your blood pressure, and then beta 1 would increase the systolic by a little bit. Does the blood pressure go up or does it go down? It goes up, so it can't be isoproterenol. Finally, you have albuterol, which is beta 2. Beta 2 is only decreasing to an equal amount, going down to equal amounts. Systolic and dystolic, systolic and diastolic. If the difference between here and here is going to be like around 40, then the difference between around here is around 40. So it can't be albuterol. So now we're stuck with two answers. We have to either figure out if it's epinephrine or norepinephrine. So let's take a look at our information. I'm going to work my way backwards just so you can see that you could have picked any one of these and try to deduce it. So I'm going to start with propranolol first this time. So propranolol is a beta blocker. It will block both alpha and beta. So let's take a look. In the case of norepinephrine, you eliminate the beta, and then epinephrine, you eliminate the beta 2 and the beta 1. In both cases, you only have an alpha 1 left. If you have only an alpha 1 left, this is pretty close together. And so you can't really tell anything from propranolol other than it's epinephrine and norepinephrine. So it's not propranolol. You can't tell anything with propranolol. It doesn't distinguish the two. The next thing, you can look at methylamine. I'm going to work my way backwards to the one that you're actually going to find useful. So control, the control is going to be not affected by this ganglion blocker. So everything that you're doing is going to be a direct effect. There's no reflexes involved. That's all it tells you with methylamine. So this one's not really useful either. So your answer is going to be within this diagram over here. So alpha blocker, what does alpha blocker do? Alpha blocker gets rid of alpha 1 and alpha 1. So the only thing that you have left is going to be a beta 1 and a beta 2. Now, what happens if there's only a beta 1? If there's only a beta 1, only systolic would increase. So did the systolic increase at all? No, it went down. And that's because epinephrine has both beta 1 and beta 2. Beta 2 is the one that decreases the blood pressure. So it has to be epinephrine for this one.